Okay, everyone, we're going to solve some radical equations once again. Here we go. So in example number 13, what we have here is basically a multiple choice question. This is the kind of question you would see on a district or state test, okay, where they actually solve it for you. But the question is, are all the steps correct? So what you have to do is go through it as if you're doing it from scratch. So if we look at step 1 right here, I hope you agree the first thing you're going to want to do is square both sides, right? And if you look at step 2, they squared there, they squared there, and so therefore that's a valid step. And then the square, of course, cancels out the square root. I'm left with x minus 3, and negative 1 squared is 1. And then, of course, I would add 3 to get 4. So everything is done perfectly, but there is one simple mistake. If you go back to step 1, can a square root, just think, if you did a square root on your calculator, could it come out to be a negative number? No. So, all the algebra was done perfectly, except you can't solve a square root equal to any negative number. So let's look at our choices. Which statement is an accurate interpretation of the student's work? A, the student made an error in step 1. B, the student made an error in step 3. C, the student found the correct solution to the original equation. D, x equals 4 is the solution to the equation in step 2, but not in the original equation. And that is the choice. Because if I plug in 4, guys, right? Or actually we'll go back to the original. The original equation right up here says 1 plus, now let's plug in the 4. Now 1 plus, now square root, 4 minus 3 is 1, equals 0. And what is the square root of 1? It's 1. Is 1 plus 1 equal to 0? No. So that's why the choice was D. Very tricky question, right? Okay, let's look at example 14 here. So in this one, they're talking about equivalent equations. So what you do on this one is you solve it step by step, and then you check to see if your steps are being shown here. As I was saying, we're going to solve it. So I'm going to rewrite it here so I can show all my work fairly neatly. So I hope you agree the first thing we're going to do is minus 5 both sides. So our square root is now by itself equal to negative 5. Just like the last problem we just did, notice this one is correct, right? Now, what would be the next thing we would do? We would square both sides. Well, the square root would go, we'd have t plus 1 equal to 25, because negative 5 squared is positive 25. Notice, that's what they have here. That is a yes. And of course, minus 1, t would equal 24. So, as you can see, we would also say yes there. Now, the only thing I don't like about this problem, just like example number 13, you have to understand that this is really going to end up being an invalid solution. So, therefore, I think we should change this to a no. Because, again, if I plug in 24, I get square root of 25 plus 5 equal to 0. And square root of 25 is 5. Is 5 plus 5 equal to 0? No. All right, let's get to some regular problems, and we'll talk about, well, it'll come up. Extraneous solutions, as we say. Okay, let's look at example number 15, guys. So I hope you agree we're going to square both sides. Now, what makes this one evil is the left side's nice. We get negative 3x plus 33. But, guys, when I square that binomial, remember the distributive property, I got to times this together. So I got to do 5 times 5, 25. 5 times minus x, minus 5x. Minus x times 5, minus 5x. Minus x times minus x is plus x squared. So I have negative 3x plus 33 equal 25. I can put my x's together. Minus 10x plus the x squared. I have a quadratic, which means I got to get everything together equal to 0 and use either the quadratic formula or factoring it. Well, let's get it all together. I'm going to add 3x to both sides. 3 minus 3 is now 0x. I'm going to minus 33 both sides. 33 minus 33 is also a 0 if I misspoke there. 3 minus 3 is 0. 33 minus 33 here is 0. What do we get over here? Well, let's put it in order. Let's put the x squared first. 3 minus 10 is minus 7x. 25 minus 33 is minus 8. So now we're going to solve with the x method. I know I need this negative 8 for my product, as we say. I need a sum of negative 7 in the middle. Notice that 2 times 4 is 8, but that does not give me 7. So my only choice is 1 times 8 to be 8. And to get the minus 7, I need to do 1 minus 8. So these are going to be my numbers for my factor. So 0 will equal x plus 1 times x minus 8. To solve here, x has to be negative 1. To solve here, x has to be 8. As we've already discussed with the previous examples, guys, negative 1 will not work. Or wait a minute, let's stand corrected. Actually, I think we better, we almost got, as I was saying, evil, evil, evil. Let's plug it back in. Notice that I'm going to plug in negative 1 here, guys. I get the square root of negative 3 times negative 1. Let me use blue. Plus 33, right? That's 3 plus 33, which is square root of 36. That's a 6. Notice on the right side, before we did all that math, we had 5 minus our x, which is negative 1. And isn't 5 minus negative 1 5 plus 1, which is 6? So negative 1 actually worked. But when I plug in 8, guys, into here, isn't 5 minus 8 a negative 3? Can this square root, whatever it is, equal a negative? No. So 8 is what we call extraneous. Think of extra, guys. It's extraneous. Okay? Which means even though, like in example 13, it worked out algebraically from beginning to end, when you plug it back in, it just doesn't work. You can't have a square root here. Let me clean this up. See, this is a square root right here, right? And over here, how can it be a negative number? It can't. A square root will always give you a positive number. Okay? So that's why 8 is extraneous, but negative 1, when I plugged it in here, gave me a 6, a positive number, so we know it worked. So negative 1 is my only solution. Okay? So hopefully, guys, I know this is tough. We're going to be practicing this for at least several more days. All right? I'll see you in class.